reality. And that brings us to this huge and often kind of invisible problem, what's called the digital language divide. It's this enormous gap where most of the world's 7,000 or so languages are just completely left out of all the tech progress we see.
Now, this isn't just a minor inconvenience, right? It's a fundamental barrier. A barrier to information, to essential services, and really to just being part of the global online conversation. It creates this silent kind of digital exclusion, basically pushing entire communities
Put the
to
old
the
way
side.
of doing things next to this new approach, you can see just how radical this shift is. Old systems, they only focus on a few dozen major languages and needed these huge, perfectly labeled data sets. Meta's approach? It can work with just a tiny bit of data. This isn't just a simple upgrade. It's about completely democratizing access for communities that have, until now, been totally overlooked. Just let this number sink in for a second. Over 1,600 languages. That is a massive leap from the, few dozen that most systems support? We are talking about hundreds and hundreds of languages getting a digital voice for the very first time. It's incredible. So what is this thing exactly? Well, at its core, Omnilingual ASR is one gigantic AI model. Its whole job is to listen to spoken words from a huge number of languages and just turn them into written text. Basically, it's one model to understand them all. Now, I know this might sound a little bit like magic, but there is some seriously brilliant engineering going on behind the scenes. So let's peel back the curtain and see how this system can possibly learn so many languages.
Process is kind of like that. First, the model just listens to thousands of hours of raw, unlabeled audio from all over. From that, it starts to figure out the core patterns of how humans speak. And once it has that foundation, it can adapt to a totally new language with just a few specific examples, without having to be retrained from scratch every single time.
So the theory sounds amazing, but the big question is, does it actually work in the real world?
And the accuracy is pretty staggering. For almost 80% of all the languages it supports, the error rate is less than 10%. To get that level of precision across such a huge